Good morning. Welcome to HashiTalks Build and my talk today about maintaining the Databricks Terraform provider. It's really been a journey of growth and learning for myself, so I would love to share it with everyone. So, a quick introduction about myself. I am Vuong, a lead solutions architect at Databricks. So we're the Lakehouse platform, providing data and AI solutions for customers. And I focus on supporting our customers deploying our solution at scale using as much, automation and production grade toolings as possible. And obviously, infrastructure as code is a big part of that. Having worked with Terraform for the last 5 years, really enjoyed the tools and working directly on supporting the users with the provider. It really gives me a different perspective, in how this old ecosystem ties together. So a little bit about, where we are with the Databricks provider. And so it's officially maintained by Databricks. So you can see us as a partner provider on the Terraform registry. The download stats are quite staggering. We've got to over 30 million downloads all over time. We're getting hundreds of thousands of downloads a week. So you can see the wide impact and the wide usage of our provider. The contributions comes from all over the world, both externally and internally to Databricks. And you can see sort of my profile picture there, Doraemon face, on the list of contributors. But you can see also some of the very important contributors there. The first person there is Serge. You know, he has the most contributions to the Terraform provider, was lead maintainer. You got Alex Ott, who's been doing awesome work as well. And you got Sri Tikireddy, who's one of our long-term solutions architects, actually started this whole project. And then you got, an awesome engineering team. You got Miles, Tanmay, Peter, there's a lot more names. If I keep listing them out, I will run out of time. But where do we start, till we get to this, current state? So obviously, working on the Terraform provider is really rewarding for me. And why? Because obviously I am a regular customer of Terraform, and my customers, my clients also use it on a regular basis. For me, it allows the technical side of me to get better. Want to do coding, and I think Golang is a pretty good language to learn. It's quite fun to work with as well. And I think other than that, I would really enjoy helping other people solving their problems, especially when you use the Databricks platform. So automation is a big part of that. And if you ask me, like, how do you contribute to the provider? And I think there's quite a few things, no matter how small it is. So documentation, sometimes is wrong. You can fix that by raising a pull request. If there's a bug in an existing resource, you can implement a bug fix for that. Sometimes just small behavior change. You can also implement the change. And if there's new features, new product, you can obviously help implementing a new resource, a new data source into provider. And I will actually talk a little bit later about how that has evolved over time. So my first few contributions, as you can expect it, are minor documentation fixes. Was back in 2021 and 22. A couple of minor changes, documentations, and then an end-to-end guide to working with Unity Catalog, which is one of our flagship feature, and in particular around governance. And then I move on to work on some small bug fixes, add some code contribution. You can see less than 100 lines of code here to address some edge case behavior. And if you look at the change itself, some very minor portion of it is to do with adding some logic. Chunk of that is to add more testing to validate. My changes have fixed the issues, but also I don't introduce any accidental regression. And then a bigger PR where I was addressing some behavior changes in our resources. In this particular case, we want to add ownership to Unity Catalog objects. So this change requires quite a lot of lines of code changes. There's a lot of back and forth comments and feedback from the maintainers. And we touch quite a lot of files there. You can see it's like 20 file changes there, lots of back and forth before it get merged. And then, adding a new data sources, that's another big pull request. So start small, and become more familiar with the code base and then add my contributions to it. That's really cool. And someone said, the journey of 1,000 miles begins with one step. Some philosopher, I might imagine, but it's actually the same story for our Terraform provider as well. So I did a bit of code archaeology to look through the first, second, all the initial releases, how it evolves, and have a little story to tell. So the first release was a Databricks Labs project. So this was a field maintain project by a couple of field engineering folks at Databricks. And I mentioned earlier, Sri was the first put the first release in April 2020. So that's our 0.1 release. It was fairly basic, right? Mostly that has a Databricks client in Go and has some basic resources built on top of that. We didn't really have unit tests. Mostly we just have integration tests for the entire thing. We didn't even have documentation that is on Terraform registry. The documentation was just in GitHub. And you go to the code and you look at it, and it's fairly straightforward, right? A resource is defined using the Terraform SDK, the plugin SDK. So just have the create, read, delete methods here. We don't have an update because the secret cannot be updated in Databricks. You have to delete and recreate them. But we also define the schema, using the standard approach, right? We define a map string, schema to schema, and then each of the attribute, you define the type, whether it's required, false, news, other properties of that. So far, so good. And the function, again, this looks pretty straightforward, right? We need to take the resource data, and then for create, for example, we need to just return nothing unless it's errors. And what we do here is the key part I'm highlighting here is that we actually have the Databricks client that essentially provides a wrapper around all our API calls. And this part is important to our story later, but so far is very straightforward. We take the resource data, extracts certain properties, and then we make the right call to create the secret. And we capture it to set the ID. And that's all we do. And you copy and paste and repeat this many times for as many resources we need. Jump forward a year later. So besides adding more resources, what else have changed significantly? So we're at version 0.3.3. At this point, I would call it a decent provider. Right? We've got Terraform registry documentation in 2.2, 0.2.2. We've added unit testing, in the next release, 0.2.3. We actually refactored the code into cross multiple packages in 0.2.4, and that's quite significant because that allows us to, improve our testing, and also working across the code base is more straightforward. We then use GitHub Actions to do our release and our testing, in 0.2.9. We upgrade our plugin SDK to V2 in 0.3.0. And then a very crucial feature, the experimental resource exporter, we added them in 0.3.1. And this is a really awesome feature that maybe not everyone who uses Databricks is familiar with. This allows you to point the Terraform provider binary to an existing workspace or an existing Databricks account. And what it will do, it would scan define the specified resources, generate the relevant HCL for those resources, import them in the state so that you have your Terraform code ready to go. And this works really well in scenarios where people either don't know how to write a resource, they might create them manually and then do the export to have the HCL automatically created for them, or they already have an existing workspace that have objects created manually, semi-automatically exporting that. And shout out to Alex Ott, who's actually been doing quite a lot of work on improving the functionality. There's a lot of awesome improvements in this around incremental listing, around adding more support for resources as well. But the work started, very early on. So let's take a look at the code base changes, in 0.3.3. So you can see the packages are all, refactored into it. We refactored them based on their based on the functionalities. But actually, there's some, big refactors here. So if you look at a secret resource, again, the same resource, we now have a couple of utility functions, like a common resource that essentially removes some of the boilerplate code when you want to create a Terraform resource. This still requires you to provide a schema, but then the create function now is a wrapper around, we have a context and we comes with a Databricks client. So that is all easy to use. And obviously this client now comes with, multiple set of API. And the awesome things about having a common Databricks client here is that it standardizes a lot of the authentication mechanisms that when you're contributing to the code base, you don't have to worry about that as well. But the code is a little bit simpler than the previous version that we saw. There's some more refactoring code gets done. So at the end of 2021, our provider is only a year and a half old. We had 0.4.0, and that was a big release. When you look at the developer's economic now, if you want to contribute to the provider, there's actually a lot of improvements. We now have a common client Go package that provides the Databricks client. As I mentioned, it handles a lot of the authentication options automatically. Because we have support for personal access token, we're supporting Active Directory, so all the integrations, from using like client secrets and using managed identities. We support integration with Google Cloud Identity as well, and our in-house OAuth implementation. So all of this has supported by having a common Databricks client. And then we put together a lot of resource definition function into a common resource.go. We actually add a fixture, resource fixture to help with unit testing, show you a bit later. But there's also some awesome helpful functions like structure schema and structure data, because what's better than being able to define the struct in Go and then getting that automatically populating a Terraform schema, right? So you can have your resource schema without using a known struct rather than having to redefine them. And we move our acceptance testing infrastructure away from just bare scripting to actually using the Terraform testing framework with some wrappers around it. So if we take a look at the testing fixture, which I find really cool. So our resource fixture basically lists out the expected HTTP fixture call to be made. And then when we say we want to, in this test, we want to read an existing secret with a particular ID, the fixture effectively validate that we're actually making the right call, and then assert that the data being the various attributes being read into Terraform is the correct one. And that's very cool. And there's some other helper function as well, like things like apply no error, apply and expect data as well, which even save us from doing more assertion. So little developer ergonomics improvements like that goes a long way when you are a new contributor and you start adding code to the code base. And if you look at something like the acceptance testing here, where we can inline our HCL template, with variable substitutions, and we can have different steps where we can validate, existing state of the environment, or we can delete objects that may have been left over as well. And then we can also put conditions around, environment variables to skip particular tests if it's on a different cloud. So sometimes we don't have full feature parity across Google Cloud, Azure, and AWS. We might want to skip certain tests, or we want to test an environment that has certain features enabled. So you can do all of that, using environment variables as well. So all of this makes contribution to the code base, I would say, easy for developers, but also it gives certainty and stability guarantee to maintainers. When we review a PR, we can run the test, we run the acceptance test, and we validate that it all works as expected. So building on top of all of that stability and the, I guess, wide usage of the provider, in June 2022, just over 2 years later, we decided to make the provider generally available, which move it from a field developed and maintained project to an official project, officially maintained and supported by our Databricks engineering team as well. So we did a whole blog post on that, and also we mark the first major release, right, version 1.0, and that give us a big milestone. We now have confidence in our provider that we're willing to provide official support. Customer can raise support ticket, go through our official channel, and we have our support engineering doing their great work to help customer debugging, all the common issues that they have. And so what happens then? Where do we go from there? So let's take a detour slightly, because we talk a little bit about, how we have a wrappers around the Databricks APIs, handling authentications, handling different retries, service definition, handling, paginations, for example. Why don't we then refactor that out and turn it into, a developer kit? So that's what Serge went ahead and did. A few months later, he did a lot of work refactoring the common functionalities, in that was in the Terraform provider, but that really should be factored out into a separate SDK. And he released that as an SDK for Go. What that means is we now have another library that can be used, for other tools as well. You can build utilities on top of it, and Terraform would then just have a dependencies on the SDK for Go. But then how about we go for a step further and to make sure that all our APIs are internally documented as using Open API spec, having some customization on our side, and then just use that to code gen our documentation and our SDKs. So if you check on our website, we now have support for a Python SDK, Go SDK, Java SDK, and even our API documentation are all automatically generated. So they're all in sync and they all follow the Open API spec, which for me as a maintainer saves a lot of time, because what I used to have to do is go through, define the relevant struct to match the API, actually testing it out, figuring out how the APIs are called, and wrap all of that, in my Terraform definition. Now, as long as the team document the API and Open API spec, the SDK would generate the right method, the right service definition, the right struct, and then all the authentication and retries actually happens in that layer as well. And I don't have to worry about that. And then now my code in Terraform is a lot shorter. So, but that brings itself to a little bit of refactoring necessary. So at 1.10, we start the migration process. So Serge raised a PR, address some fundamental changes, which is the HTTP client layer, the configuration layer. We move those to the one defined in Go SDK. And we kind of know the compatibility because the SDK implementation actually inherits a lot of the Terraform client implementation. But then for the different resource in the data source, we do need to migrate them, one by one. So we can migrate some of the simpler data sources. Some of the resources are actually quite straightforward to migrate. There are some more complex ones. So typically in Databricks world, a definition of a cluster, for example, which is essentially, how a compute unit is defined, is quite complex because there's a lot of configuration you can add to a cluster. Your node type, various Spark configuration, whether you want Spot or on-demand instance type, the runtime. So there's a variety of those, and the code base actually has a lot of logic and customization in the schema to detect the drifts, to do validation. So migrating that to Go SDK takes a bit of time. And then you have more dependencies, resources that actually wraps around that. For example, a job, right? Because a job itself can consist of multiple tasks. Each task can then refer to a cluster. So there's a lot more dependencies, and we need to make sure like the spec is documented correctly, but also all the customization, all the validation, edge case behavior are maintained in Terraform. And to help with that, right, we add more functionality, more quality of life improvements as well. Not just focusing on migrating the resources to SDK, Go SDK, or just adding new resources. we have more generic utilities now because reusability and ease of use or ease of contribution is important. So adding data sources now with Databricks provider is very simple because we have generic utilities now, and that's been available since 1.21. We added merge queue, which helps us with managing, multiple PRs and merging them, so increase our velocity. We actually massively simplified now how we do schema customization, because when you want to mark certain field as conflicts with at least one off, we have all of that now well defined. We actually allows you to create your own custom struct and comes with a schema customization as well. And for unit testing, so the fixtures is cool, but then you still have to write your HTTP methods. Because the Go SDK now supports mocking library, we actually can use that now in Terraform unit tests. And I've really liked it because it avoids certain assumptions built into having your provider behavior depends on certain calls, the HTTP calls, which in fact, can change. The SDK is already wraps around that and it handles a lot of it. So our unit testing shouldn't be depending on the methods either. And using mocking libraries makes our testing a lot simpler. And there's also quality of life improvements for maintainers. We now auto-generate the changelog based on all the PRs that are merged, and then we present that for manual review. That gives us ability to do a lot more detailed changelogs, but takes a lot less effort. So there's a few anecdotes, a few, I think interesting lessons learned I picked up, as I start contributing and then become a maintainer for the provider. I think here's probably a fun one I had about, an innocent sounding request, but then becomes a very long-winded process. And it gives you a bit of perspective into sometimes when people raise an issues on GitHub and it takes a while for the root cause to be addressed, and then we can fix that. And working with maintainers sometimes feel frustrating. But Unity Catalog was a big feature, it's our flagship feature for governance. And there are requests in 2022, December 2022, to add support at the account level. And why? Because people want to be able to manage their assets, across workspaces. So they don't want to have to go into individual workspace and have a lot of dependencies there. So we went back, request our engineering team to add the relevant APIs, which was done. They released the preview version in March 2023. So I started working on that. Well, unfortunately, the draft PR got created, but then when I was doing my testing, I ran into a lot of bugs. And at the same time, while I was waiting for the bug to be fixed, and as they're going through the preview process, they update a lot of the behaviors. I keep going through the code base, and one of the challenges is that making sure that backwards compatibility behavior remains. And so that's why you can see in the PR, there's a lot of commits. The changes actually affect multiple resources and multiple files. So in July, we finally got working APIs, but unfortunately, the spec that we defined internally was not correct. So we spent the 4 months fixing everything, but actually the last step was not available because our Go SDK is auto-gen from the API spec. And if the API spec is wrong, the SDK methods would be wrong as well. So it took us another month to have the release. So over end to end, it took us more than half a year to deliver this very highly requested features. It was very satisfying in the end, because in the end, you see on the right hand side there, the example, right? With this, I have a massively simplified code that deploys, different metastores in different regions with 10 lines of code, which before it was complete pain, was not straightforward. But the inner workings, the different layers, the different interactions, working with different engineering teams, can lead to delays. And sometimes people, as users, they do feel frustrating about the process. And I think working as maintainers, you have to balance and having as much communication as possible. And then there are lots of anti-patterns that I found running into it, working with folks. And I think some of it comes from the limitation of the tools, some of it comes from limitation of the platforms. And not everyone's aware of it, unless you're actually working actively on the provider. So for example, customer wants to manage tables in Terraform. Sounds like a nice idea at the beginning, but obviously Terraform determine differences is not quite the same as a table, because certain changes in a table requires a drop and recreate, and certain changes can be updated directly. And Terraform, to be able to handle all the edge cases and the complexity there, will make the code almost unmaintainable and actually duplicating a lot of logic that will actually be, in our runtime. So managing tables in Terraform, I think eventually we end up with an experimental resource that generate SQL statements and have very blanket rules about what's updatable and what's not. But obviously, we can't handle a lot of the edge cases, and the experience is not very smooth. And I feel like that's an anti-pattern for managing schema tables changes. I think purposely built tool is still better. There are some limitations in our platform where, for example, our permissions API only supports complete override, and customers want Terraform to either, supporting managing permissions both, I could say, automated way via Terraform, but also manually add. Well, unfortunately, that is not available in the tooling, so it makes it very difficult. And also, I think explaining the behaviors and trying to find a workable solution can be quite difficult and challenges in this case. All simple things like having customer want to manage all their resources. So all the resources within a workspace, they want to store them in one state file. But obviously, if you have lots of users, lots of compute, lots of artifacts to manage in there, your state file grows unmanageable, and that will slow down the Terraform plan processes. It actually slows down the apply, run into rate limiting on the API side. And I find working with those, it's as a maintainer, giving suggestions, on how to use a provider effectively, again, there's more communication required. So let's look forward, into the future. Like if you ask me, like what's the major changes in the next, 6 to 12 months time, I would say there's probably three big things. We need to migration to the Terraform plugin framework because SDK v2 has, given us quite a long runtime with it, but we still have some known bugs that we cannot resolve without moving to plugin framework, especially when you have to determine the diff or the changes, by actually looking at the difference between config and plan and state data. And a lot of the handlings around nulls, for example, we need to move to plugin framework to be able to address this though effectively. At the moment, there's a lot of hackies, workarounds, and there's a lot of implicit bugs in the provider that we're just not very happy with. But migrating to the plugin framework will take some time. And a couple of engineers actually working sprints through this. We want to be able to auto-generate, new resources from the Go SDK as well. So take the auto-gen one step further. And I think we've got some good ideas on how to do that as well. So we would generate a template and then do some a little bit more work to finalize and to create the documentation and release that. So hopefully maintaining, adding new resources support should be even faster going forward. And I think that the big ones is for customers with multiple workspaces and, and not working with customers who have hundreds of workspaces, the requirement to have a provider instance per workspace is quite limiting. So we're working on a change that hopefully will allow a single provider that can manage multiple workspaces, given some pre-setup first. Hopefully that will simplify a lot of deployment patterns, and I would be very excited to be writing some more guides around that. So that's about it. And thank you very much for listening to my lessons learned about maintaining the Terraform provider. And any questions, feel free to ask and feel free to connect to me, on LinkedIn. And or, if you are actively using the Databricks Terraform provider, yeah, reach out on GitHub, raise any issues you have, any questions. Thank you very much.